Within JavaScript, functions are the fundamental way of defining reusable code blocks. We've been using functions all along this course, whether it was console.log or the various methods that we looked at when working within the data types. So in this tutorial, we will kick it up a notch and take a deeper look at how you can create your own functions and lots of their technical features. Even if you've used JavaScript for a while, I can guarantee that you will learn something new in this tutorial, so let's go. Let's first discuss the main objective of functions, and that is code reuse. Consider we have a value and a % discount and we want to calculate the discounted value. We can do that quite easily with a JavaScript expression, but if we want to do it again for a different value, we will have to write that expression again, and this sort of code is not very maintainable. And this is where functions come in. We create a utility called calculate discounted value that takes a value and a % discount, calculates the result, and returns that from the function. And now whenever we need the discounted value, we simply invoke the calculate discounted value function, and it gives us the result that we are looking for. Let's take a deeper look and discuss the various JavaScript syntax elements that are at play right now. First up, we have the function declaration. This consists of the function keyword, followed by an identifier for the function name, followed by the various parameters that the function can accept, followed by a function body that consists of various statements with an optional return statement to return a value back to the caller. To use the function, we make a function call. There are two function calls over here, and the structure of the function call consists of the function identifier followed by brackets where we pass in the different arguments that get assigned to the parameters within the function. A curious fact about function declarations within JavaScript is that they get hoisted, which means they can be used. For example, we can call them or invoke them before they have been declared. And just like other JavaScript data types, the type of operator is supported for functions as well, and it returns the literal string function. JavaScript functions are fairly resilient and they will actually work without throwing an error, even in the presence of possible coding mistakes. So even though this function only accepts two parameters, we can actually pass in 3 arguments, and what will happen in this particular case is that the third argument will get unused, which is pretty much the same as just putting a random string somewhere in our code. It's not doing any harm, but it's not doing any good either. What is more dangerous is that we might potentially forget to pass in a required parameter. In this particular case, we have forgotten to pass in a % discount, and the JavaScript runtime will actually pass in that magical value that we've looked at before called undefined. Additionally, trying to do math between a number and an undefined value will give us another thing that we've looked at before in our number lesson, which is the NaN special type. The obvious guidance here is that don't pass in more or less arguments than you need, because the JavaScript runtime may or may not throw you a useful error. Return statements in JavaScript functions are optional, which means that not only can we use functions for calculating results, but we can also use them for carrying out tasks where we do not need a return value. As an example, consider a simple sayHi function whose sole purpose is to log a full name to the console. And of course, if you pass in an object that has the first name and the last name, it will calculate the full name and log that out as you would expect. What is interesting is that functions always return a result within JavaScript. So we can actually store that result and log it out. And because this function does not have a return statement, JavaScript returns that special value undefined. Now this is perfectly fine as we do not expect this function to return a value. However, it is easy to make a programming mistake where you forget the return statement when you intended one, in which particular case you might end up with an undefined. So obviously, don't forget your return statement if you need one. Modern JavaScript offers a special syntax to take a single array argument and turn it into multiple parameters that get passed into the function. You might recall the math.max function from our number lesson, which returns the maximum value that exists between the different arguments. Arrays in JavaScript are a simple collection of items separated by commas within square brackets, and here we have an array of 3 items. Now if you wanted to pass these individual items from the numbers array to math.max, we would have to look up the individual items. We would have to look up item 0, then item 1, and then item 2 as different arguments that we send to math.max. And this is where spread arguments come in. We can actually take an array and use the triple dot to spread those array members as different arguments that get passed to the function. Just to get a bit more practice with spread arguments, consider a simple example function that takes 2 values, a and b, and we have a message array that consists of 2 strings. If you want to pass those 2 strings into the example, we can take that array and spread it into the different arguments. Within JavaScript, functions are first class. This is a programming language concept, and what this means is that functions can be treated like other data types and moved around as variables and even passed into other functions, which are called higher order functions. We can actually take a full function declaration and assign it to a variable, but this will actually not be a function declaration as we saw before, and instead, this will be what is known as a function expression. What this means is that the identifier for the function, which is example, is not going to become available in this scope. And our only access to this expression is where we assigned it to. Here we assigned it to hello, and we can use that to invoke the function. Now obviously, since the function name does not become exposed, it is common to use function expressions without a name, and these are known as anonymous function expressions. Now when we are using functions as variables, they are going to follow the rules of the variable. For example, here this is a let variable, which means that we cannot use it before it has been assigned. Another common use of a function expression is in a pattern what is known as an iffy or an immediately invoked function expression. Consider a simple function example that we want to invoke immediately. If this is the only time we invoke this function, then we might as well just use a function expression and wrap it up with parentheses and invoke it immediately. And now that we know what function expressions are, I think it makes obvious sense why this is called an immediately invoked function expression. Now just like we can assign a function to a variable, we can even pass it in as an argument to another function. For example, here the runTwice function takes a callback function and invokes it twice. So when we call runTwice, we can pass in a function that logs a message hello world, and then runTwice will run it twice, giving us two console.log messages. Now functions that take other functions as parameters in programming language terms are called higher order functions. And they show up in JavaScript all the time. For example, there is a built-in function called setTimeout, which takes a callback parameter and a duration in milliseconds, after which that callback will be invoked. So this code will log a second has passed after 1 second, and we can make another call after 2 seconds and log out 2 seconds have passed. Now of course, if we run this code, we see a second has passed, and after 2 seconds, 2 seconds have passed. Beyond setTimeout, we will look at lots of functions that are built into JavaScript that work on top of callbacks. Inspired by functional programming, modern JS offers a neat syntax for defining functions called arrow function expressions. Consider a simple sum variable where we want to assign it a function that takes two arguments, a and b, and returns the sum of those values. Now of course, we can use a function expression and that works fine, but there is a newer syntax called arrow function expressions which allow you to shorten the amount of code that you need to write. Syntactically, you drop the function keyword, provide your parameters, use the equals and the greater than sign to create what is lovingly called an arrow, followed by the function body. Now if your function body consists of a single return statement, you can shorten it even further to remove the body curly braces and only use the expression that you were previously using in the return statement. And if you only have a single parameter within your function, for example add10 only has a single x parameter, then you do not even need the parentheses around that parameter. JS functions offer a special parameter syntax that allows it to accept multiple passed-in arguments as a single array, and these are known as REST parameters. For example, consider a simple log function that logs the value of two passed-in parameters. Now of course, this works perfectly fine when we pass in the required number of arguments, but it doesn't work as well if we pass in only one argument. As we know, we are going to get undefined, and it completely ignores any additional arguments that we might pass in. For example, we are passing in 1, 2, 3, and 3 is completely ignored. The original console.log method that we are wrapping actually works much better. It works with one argument, it works with 3 arguments, it works perfectly fine irrespective of how many arguments we pass in. And this is where REST parameters come in. They allow you to take a variable number of arguments and convert them into a single array parameter. So now if we call a log with 1, 2, 3, we get all of these 3 arguments converted into a single array, and as you can see, that is what gets logged out. One thing to note is that REST parameters do come in as a single array, but what about that objective of making it similar to console.log where it would log out 3 different items? To do that, we would need to invoke console.log with multiple arguments, and we already know how to do that because we just looked at spread arguments. So we can take this single array and spread it into multiple arguments when we are calling console.log. Now one more thing to be aware of with REST parameters is that it must be the last parameter within a function definition. So if we use triple dots before any other parameter, we would actually get a syntax error. Now, of course, we can mix rest parameters with other parameters as long as the rest parameter is the last one. Here we have a nice prefix log function where the first argument is a prefix that is going to be pretty printed, followed by the rest parameters. A welcome modern syntax offered by JavaScript functions is the ability to define default parameters. Consider a simple sum function that is designed to sum three numbers. Now, of course, if we pass in 1, 2, and 3, it is going to provide the sum, which is 6. But if we forget one of the arguments, we're going to get back that thing that we looked at before called not a number. This is because we just tried to do math on an undefined. We can actually provide a default value for a parameter by adding an assignment expression after the parameter name. So this still works if all those three parameters are provided. So 1, 2, 3, sum it up, we get 6. But we can also provide only a few of the arguments. For example, only provide 1 and 2, and we get back the sum 3 because C has defaulted to 0. One thing to know about default parameters is that they basically work on top of undefined, so we can actually use them in any position. And if you want to use the default value for any of the parameters, simply pass in undefined for that particular argument. So here, since we are passing undefined for B, B is going to default to 0, and 1 plus 0 plus 3 equals 4. If you've worked with other programming languages, you might be familiar with the concept of arguments being passed by reference versus passed by value. Let's take a look at what this means and how it applies to JavaScript. In JavaScript, arguments are always passed by value. What this means is that assigning the parameter to a new value does not impact the original argument. And this is true for all types. For example, here we have a primitive number, and when that gets passed in, we try to assign the parameter a new value, but the original primitive still stays at a value of 3. And we can verify that the same also works if we were to accept an object. For example, here we have an object with the property name of value John. We pass it into the function, and the function tries to do a reassignment, but the original object, of course, remains unchanged. Some programming languages have a concept of reference parameters that allow such reassignment. That is not something that is supported by JavaScript. A great mental model to have is that the conversion from argument to parameter is the same as assigning a value to a variable. Consider that object again with the property name of value John. We can assign this object to another variable, for example person, and right now mutations to person would actually mutate the original object. But if we reassign person to a completely different object, it's going to become completely disconnected from the original object, which of course means that the original object.name will continue to be John. And this assignment expression where person equal to object is exactly what happens when we pass an argument to a parameter. This means that if we make the parameter point to something else, then that has no impact on the original argument. Now, if we take that object that person is pointing to and modify some of its properties, for example, modify the name, then of course, since person is still pointing to that original object is exactly what is going to get mutated. And since argument to function parameter is nothing more than an assignment, if we take that object and mutate it, the original referenced object is exactly what's going to get mutated. Needless to say, mutating past time values in JavaScript is normally frowned upon, as these side effects can be quite hard to reason about. So let's talk a bit about pure functions. Consider a simple global variable and an increment function which modifies that global count variable. Now, of course, this does work. We can initialize count to 0, increment it impurely, and now count is incremented. But that's not going to be particularly maintainable. There is no indication reading this code that count is going to get changed. A much better implementation is something that takes an input and returns the result. So here increments depends upon nothing other than its parameters, and it does not modify the parameter or any other global variable for that matter. Now when we use increment, we are responsible for making sure that we store the result as we see appropriate, and for anyone else that reviews our code, it will be very clear that the count is going to get changed. Just like we can use destructuring in variable assignment, we can use destructuring in function parameters as well, because after all, argument to parameter passing is sort of like a variable assignment. Consider a very simple ranged function that takes a value min and max and makes sure that the value does not exceed the boundaries of min and max. Now, of course, this does work perfectly fine. For example, we can pass in a value of 100, a min of 0 and a max of 10, and it clamps it down to the value of 10. But if someone were to review this code by itself, it would be very hard to understand which one is the value, which one is the min, and which one is the max. So a better option is to actually pass in a single object where the different keys identify the nature of the properties. And now that a single object is going to get passed in, instead of using a single identifier, we can destructure it into its members, which of course are value, min, and max. From a runtime perspective, again, this is exactly like doing an assignment. So just like within an assignment, we can do destructuring from an argument to a parameter. One of the most powerful features of JavaScript functions, and something that was critical for things like Node.js, is the JavaScript support for closures. It should come as no surprise that when we have a variable outside of the function, we can access that variable from within that function. So over here, example is incrementing alpha, and of course, once we invoke example, alpha is going to be incremented from 0 to 1. A closure is nothing more than the fact that a variable in an outer scope has been closed over and bound to a function. What is interesting is that this binding continues to exist even after the outer scope has returned. So here we have a function called counter that has a local variable called count, and then it has an inner function that of course can access this outer variable called count. Now even after the counter function will return, this particular instance of the count variable will continue to be bound to this particular instance of the function that gets returned. And we can prove this with a simple example by creating an increment function which is returned from counter, and then as we invoke it again and again, we get back constantly incrementing versions of that original count variable. We can combine JavaScript support for first-class functions and its support for closures to create a very popular design pattern called factory functions. Because functions are first class within JavaScript, we can create objects that contain functions. And because JavaScript supports closures, these functions will have access to variables that only exist within the containing function. So here our createCounter function creates an object that has increment, decrement, value, and reset functions, and all of these functions operate on top of a local count variable. So when we create a counter, we get to provide an initial value, and of course if we don't provide one, it defaults to 0. And then our only access to that variable is via these controlled methods that are a part of the returned object. As you can see, JavaScript functions by themselves allowed people to create some pretty well-structured modules even before the support for native classes was added. When we are defining functions within objects, which in object-oriented programming are called object methods, JavaScript provides an additional shorthand syntax called object method definition. As an example, consider an object cat_dog that has a method called speak, which is a function that logs two simple statements. Here we are using the key value syntax of objects that we have looked at before, where speak is the key and the value is the function. The object method definition syntax gets rid of that colon, gets rid of the function keyword, and provides a much tighter experience. There is no functional difference between the two. If the body of the function is a simple expression, I would use an arrow function, otherwise I would use the object method definition. Defining functions as a part of objects also unlocks two additional types of functions, which are getters and setters, which look like functions when we define them, but behave more like standard object properties when we try to use them. Consider the example where we want to create an object that has a single property called value, but we want to make sure that whenever the value gets set, it stays within a range of a minimum and a maximum. We can do that by providing our own custom setters and getters for the value property. Instead of defining a property like you normally would with the colon, we use a modified syntax of an object method definition where we precede that by either the get keyword or the set keyword. Let's discuss the behavior of these getters and setters a bit more by first creating an instance of this object. We use these just like normal properties and not really methods. For example, we can read the result by simply range.value. This will internally invoke that function, but for consumers, it feels like just another property. We can also assign a new value to this property, and internally it will invoke the function for the setter and pass in the new value. But again, in terms of consumers, it feels like just another property. This ensures that the value can never escape the range that we originally provided, which is 0 to 10. And as you can see, the updated value goes to 10 instead of going to 15. In case you were wondering, you can create recursive functions in JavaScript, that is, functions which in their body make a direct or an indirect call back to themselves. And a classic example of a recursive function in computer science is the Fibonacci sequence that follows the definition that Fibonacci of 0 is 0 and Fibonacci of 1 is 1. And then for all other positive integers, the Fibonacci for n is the Fibonacci of n minus 1 plus n minus 2. So let's create a function that follows this specification. It takes an integer n, and if it is 0, we return 0, and if it is 1, we return 1. Otherwise, we again invoke Fibonacci with n-1 and then add it to another invocation of Fibonacci with n-2. So as an example for the curious, the 11th Fibonacci number should be 89, and of course when we run this, that is exactly what we get. We've covered lots of features of JavaScript functions, and trust me when I say that as a professional developer, you will interact with functions so often that it's good to be aware of all the tools that you have available in the JavaScript tool belt. As always, thank you for joining me, and I will see you in the next one.